Okay, in this lesson we're going to go over some geometric operations you can do with vectors, okay? So here I have some vectors, P and Q. Now I can add them, okay? I can add them together. I can go vector P plus vector Q. So if I draw vector P, okay, now I'm going to add vector Q. So where vector P ended, this is vector P, I'm going to start vector Q. So it starts and goes off. Here's vector Q. So vector P, it started, finished, and then I had vector Q start where the arrowhead of vector P, and then it goes to where vector Q ends. Now P plus Q, I started at the start of P and I ended at the end of Q. So my addition, we just doing that, starting and then went all the way to where it finished at the end of vector Q. So this is vector P plus Q. If I give another vector, let's say I have vector one going straight north, that's called vector A. I have vector B, a little bit longer, and it's going straight out to the side. And I can do vector A plus vector B. So I draw A. Okay, then when A finished, I draw B. And then I can go from A to B. That's where I started initially, that's where I finished, so that is vector A plus B. Okay. I can do vector subtraction. Okay, now vector subtraction is just adding the negative, or the vector going the opposite direction. Okay, so I have A subtract B is really just taking vector A and adding the negative of vector B. So here I have a new vector A, I have a vector B. If I want to do A subtract B, I'm really going to be adding, that equals A plus the negative of vector B. So what I can do is I can take vector B and draw it going in its exact opposite direction, same magnitude. And now I want to add A and the negative B. So take vector A, then where it finished, I start my negative vector B. And here I have going from vector A subtract B. So where I started to where I finished, so this would be considered A subtract B. Okay? Again, I started here, I finished there, so my final solution should start here and finish there as well. Okay? Just a shorter way of getting that. I can have vector equations. Okay, so here you have vector S. Notice vector S starts and finishes, and vector P and Q do the same thing. So vector S is going to equal vector Q plus vector R. Okay, them together, Q plus R, equaled what vector S was. If you have some equations, you can simplify them. I have vector AC plus vector CB. Now I don't know where these vectors were going. I don't know the direction. I don't know anything about them. You know, you had some vector starts at A, goes to C, then another vector that started at C, went to B. Okay, the resultant would have started at A and ended at B. And I can just simply call that vector AB. So my answer would be vector AB. Notice how they have a common point between them. Vector AC started at A, ended at C. Then vector CB started at C, ended at B. The C is common between them. So therefore the solution is vector AB. For the second question here, I have AD subtract BD. Now there is no common point between them. This A goes A to D, and then it goes B to D. What I can do, though, is I know the subtracting is adding of the negative. Now the negative, okay, would have been going the opposite direction. That would be DB, the opposite direction. So here I would have AD plus DB. I just switch the direction of the initial vector BD. So that means I went from A to D, and then from D to be wherever these points are, and so my resultant would have started A and ended at B. And again, I have a common point between them of D, so my answer is just simply A, B. On this one here, see, I have some common points. So I have A to B, then I have vector BC, then I have vector CD. I have common points between, and then I have common points joining the second set of vectors. So my resultant would have been just starting at A and finishing at D, which would be vector AD. Final thing in this lesson is scalar multiplication. If I have vector A, which has its direction, it has its magnitude, 2A, same direction, but just twice as long. I get 3A and it'd be just 3 times as long. Okay? I could have negative A. I could have negative 3A, 3 times as long, but opposite direction. Okay? So if I'm given two vectors, P and Q, and I want to find 2P minus 3Q, take vector P, and I need to double it. Okay? This is now vector 2P. And then I'm going to subtract 3Q. Well, this is Q, so subtract 3Q is going to be 3 Q's going in the opposite direction. So I have 2P, and then I want to do my negative 3Q, subtract 3Q. And then the resultant would have started where it started here and it finished over there. So this is my resultant vector right there. Okay, this is 2P minus 3Q. Started, finished. Okay? So it's a little lesson on some of the geometric operations of vectors. You can add, you can subtract, you can come up with vector equations, and you can multiply by scalars. Okay? Thank you very much.